So first of all, what are all the topics there in our mid-sem for computer organization and architecture? Yeah, thank you. Uh, so the topics are the problems that on the basis of CPI, MIPS, and execution time. CPI means clock per instruction, and MIPS means million instruction per second, and execution time means you have to find the time, how much time it has taken. So after that, you have to compare between the time and performance and Amdahl's law. So these are 16 topics. So in the videos, right, in my playlist of computer organization and architecture, right, I have posted the solutions of the model paper. So some understood the problems clearly, but some may not understood what I have done, all those things, right? So for them it will be very easy. So even if you ask doubts here, I am ready to clarify that. So I want one thing from you guys, as I haven't written the questions in the paper, the model paper questions. So parallelly you should have to open in your system or in your mobile. Okay, so main thing you have to do is you have to open the model paper that is there in the LearnBuzz. I have shared already, right, in the LearnBuzz website. So please open that. Like I will be reading the question. I have already laptop, so I will be seeing in the laptop and I will be reading the question. MIPS full form is million instruction per second, Jay Prakash. Yeah, hi Abhi. So see, I will be reading the question from the mid model paper and I will be explaining the my book, paper, with pen and paper. Okay, yeah. So I'm going to the first question. So I hope maximum members know how to solve the first question, right? How to calculate the average CPI, how to calculate the million instruction per second, and how to calculate the execution time, and after that Amdahl's law. So these topics, first of all, first question in model paper covers, yeah, hi Kavya. So first question in model paper cover these two topics, like problems on CPI, MIPS, execution time, and in Amdahl's law we are going to cover in the first one as well. 1 minute. Yeah, so let me start the explaining the first question. So please open the model paper first question in your yeah. Let me know if it is clear, like visible for you. Anyone please confirm if it's clearly visible, right? I can continue with explaining the first problem. So meanwhile, please open parallelly the model paper. Okay, so let me explain the first question. So the first question is, a benchmark program is run on a 20 megahertz processor. So the performance is given, the processor, okay, what is the frequency is given. So first of all, by reading the question, you should know what are all the given terms. Okay, so first of all, after reading the question, what you should know, you should know what are all the given terms. So in the first question, starting itself, frequency is given. Okay, and after that, the executed program consists of 200,000, like say we can say 2 million instructions, like that we can say, with the following instruction mix and clock cycle count. Okay, so you can see the table in that question as well. So whoever, like where I am reading from question, right, I am reading the question from the model paper. So please open the model paper parallelly. So if you want, I can show in my lab, but okay, let me see whether no. Yeah, please open, try to open. Everyone have opened, right? So it doesn't create, can you show the question? So okay, if you want I can show, but the main thing is that if you open in your one, right, it will be very better. So you can see this, right? Is it clear, Gautam? Guys, open sample paper. Yeah, Mustafa, please tell, like everyone please open sample paper. If you open in your in your system, right, it will be very easy. I will be reading the question in that one only and I will answer in the, yeah, Jay Prakash, yeah, please do that. Yeah, see this question, you can see this in this as well. It is clear, right? You may be, I think letters also clear in, yeah. See, a benchmark program is run on a 20 megahertz processor. The executed program consists of 200,000 instruction executions with the following instruction mix. So in the first two lines, what are the given two terms? The frequency and the total instructions. Okay, So when the table is given, what we need to find? We need to find the determine the effective CPI and the MIPS rate. Yeah, thank you, Smiley. Okay, so and after that we have to find the MIPS rate, and after that we have to find the execution time. And see, it is given like a Amdahl's law. Like one of the instruction is the speed is increased and the total speed is increased. How much percentage I have to increase in the clocks per instruction, like that? I have to find the fraction. Okay. Yeah. Hi, Swati. Yeah. Thank you. So let me explain the answer for this question. So first of all, after reading the question, you need to write the what are the given terms. Okay. So what are the given terms here? If you see, let me concentrate. Let me show this now. Yeah. Okay. See now, what are the given terms? Given processor frequency is 20 megahertz, total instruction count is 200,000. Okay, it is clear for everyone as if now. Next, what we need to do? We have to determine the effective CPI, right? So how to find the effective CPI is the first question. So how to find the effective CPI is our first question, right? So how to find that? There is a formula. So whenever you are getting a table, right, maximum, see, in as we have 8 sessions, right, I have seen the every PPT. So in the first two PPTs, the concepts are to find CPI, MIPS, execution time, and Amdahl's law. These are the topics that are there in first two PPTs. So if you cover these things, right, is the clock rate same as the processor frequency? Yeah. Yes, Mustafa. So clock period also we can write time is equal to 1 by frequency, right? Similarly, we can write clock period is equal to 1 by clock rate as well. Okay. So first of all, like see, by covering these two topics, let's see. These three topics are from the 1 and 2 PPTs. Okay. First PPT and second PPT. So now effective CPI. How to find the effective CPI? So it is nothing but finding the mean. So just remember how you are finding the mean in your like past days, like in 10th class or like that, we will be having the mean, right? Sum of the observations by number of observations. So similarly, to calculate the average average CPI or effective CPI is same. Okay. So now how to calculate that? Just in the table, you will be giving some instruction count and cycles per instruction. So for the different instructions, what are the different instructions in the table? Integer arithmetic, data transfer, floating point, and control transfer. See, I'm reading from this. So if anyone don't watching this, you can see this. You can see this, right? Integer arithmetic, data transfer, floating point, and control transfer. So these are the 4 instruction type, and the instruction count is given, and the cycles per instruction is also given. So what we need to do? Just we have to multiply 45,000 into 2 plus 32,000 into 4 plus 15,000 into 2 plus 8,000 into 5. We have to multiply it and add. Okay, see, that is the things I have done here. 45,000 into 2. See, sigma IC is instruction count into cycles per instruction. Okay, see, I will writing again. Yeah, okay, Sam bro. So again, let me write here. Sigma IC. IC means here instruction count into CPI. It is nothing but clocks per instruction by TIC, total instruction count. Okay, is it clear formula, Sham? Okay, now what we have to do? So first you are multiplying that is instruction count with cycles per instructions, but total instruction count is already given, right? So at the starting on the question only, total instruction count is given 200,000. So I have divided by that, and we will get the average CPI. So any doubts in calculating average CPI? So in some of the question, they may ask, like in place of cycles per instruction, right? They can give an instruction mix in percentage. Don't be confused. There is one question in PPT as well. So in some of the questions, they can provide the percentage in place of cycles per instruction. So what we have to do, whenever you got a percentage